fine. What we have discussed in last class, pa? Those who are active, please say me good evening, ma'am, please. Those who are active in the meets, please say good evening. Yes, Tarun, I hear Tarun. Any other?
Good evening, ma'am.
Yes, Nitya. How many people? Yes, yes. Only 40 peoples. Hmm? What about others? Forty-two, 43. Okay, fine. 44. Okay, some people in the meets, fine. The previous class also max, now also I'm going to TOC, right? That's why I'm planned. We will discuss for 10 minutes. Okay, please, all of you. We will discuss for 10 minutes about interview, how it may be. Any idea? Anyone? What are the questions they may ask in the interview? What about their expectation? Anyone know about that process? Anyone is ready? Please come forward. I will try to conduct the interview for you. Anyone is ready? Students? Just for a change, please come forward. Anyone? We can discuss about interview and I try to conduct interview for you. Anyone is ready? Just 2 questions I will ask. Are you in the meet? Please, anyone respond. I'm audible, right? Students? I'm audible, right? Anyone, please?
Yes, ma'am.
Yes, Varshini, thank you, ma'am. Anyone, please come forward. We can conduct an interview. Then we move to the TOC concept. No need. Directly, shall I move to the TOC? Please give some reply. What is about your opinion? What's your suggestion and how your because the last class also max. That's why I planned. Anyhow, if not, if you're interested in TOC concept, then we can go with the TOC. Please respond me, anyone. Shall we go with TOC concepts? You can reply yes or no, right? No other questions you asked here. From boys, anyone is ready to conduct the interview? Attend interview. I will ask questions. Anyone is ready? Is Jacob, Tarun, anyone is there? Mukesh, I just remember that name. Yes. Anyone is there? No need, Amma. Shall I start our concept? Okay, fine. You are not interested. Is what, Jacob?
Continue with the concepts, ma'am.
Okay, good. Okay, before that, no need to come forward. I will ask one question. If some interview may ask you that, please write something on the board. Okay, then how? What is the thing you may write in the board? Anyone? They're asking you to write something on the board. Okay, what maybe you write?
Something.
Who's that? Anantita. Number 10. Okay. Any other answer? They're asking you to write something on the board. What you may write? What's the idea? What's the concept comes in front of you after reaching the particular question? I need at least 5 or 6 answers, please. Only one student responded. Thank you, ma. Others?
Ma'am, we should only write, ma'am.
What, ma?
Should we only write?
Yes. Any other answer? Any other answer? Okay, fine. You can write something. They are asking, don't think much in the time of interview. Please be practical. How we can behave practical or how we can behave casual means if you are done your work well, or you can complete all, if you are completed all your work well and perfectly, then you can be in casual. Okay, so please, all of you, I just want to tell one thing is, complete your work by today itself. Okay, then only you can be like a casual person, or you can able to understand what they are telling. Okay, just they are asking you to write something on the board, then you can write something only. You can't able if you are starting with Java or C plus plus like that, if you are going means they may ask more questions on that, like that. Okay, and what are the things you have mentioned in your resume, that is very very important. They are uh, asking many question on that particular topics only. Okay, okay, with this information, shall we start TOC? In last class, what we have discussed is, last class what we have discussed?
GNF.
GNF. Okay, what's the rule for GNF? What is the rule for GNF?
Start with the terminal and can have number of non-terminal.
Okay, thank you, Pa. Thank you, Tarun. So you please make a note of this problem. This is another one question. Convert the following CFG into GNF. Okay. So homework, please try. If you have any doubt, you can ask me. What are the steps to convert the CFG into GNF? What are the steps? Try to recollect everything what we have discussed in the previous class. What is the first step? Anyone? What is the first step?
We have to check all are in C.
Yes, very good.
CNF.
We have to check all the productions are in CNF or not. Okay. Here, what is the case? This production is CNF or not?
CNF.
Yes, CNF. Very good. Okay, fine. And then what about the second step? Any others?
Assigning new variables.
Okay, we have to assign new variable. Here, how many non-terminals we have?
2.
2. So we can introduce two new variables. Okay, S equal to A1 and A equal to A2, like that. Based on this new names, we have to rearrange or rewrite our production. Okay, this is the second step. Then third step. What is the third step?
Check for I and J values.
Okay, we have to process each and every production. Okay, S tends to AA, like that. We have to take one production. In that, you have to check the I and J value. How we can check I and J value? We have to take the leftmost, left side variable and first element of the right side variable. We have to check in that. We have mentioned 1 and 2, like that, I values. Based on that, you can check. Left side element is the I value, right side element is the J value. If we are we have to compare both the things. If J is greater than I, then what is the process? I less than J. J is greater. Then what is the answer? What is the process?
Can have the same production.
Okay, we can keep the same production. We can say if the particular production is in the ascending order. Okay. Left side is the lesser one, right side is the greater one. Ascending order. If it is in ascending order, I less than J, then we no need to change anything. Okay, right? We can keep the same production as it is. Okay. The second condition, I is greater than J. Then what is the process?
Substitute the production.
Okay, each and every element of, the first element of right side production, if we have any production for that, then we can substitute. Okay, again we have to compare. Like that, it's going. Okay, and if another one condition is that if I equal to J, both the values are J, then what's the process?
Use formula.
Okay, we have to use the formula. What is the formula? The formula is not on it. Formula is nothing but bi equal to beta slash beta bi, a equal to a slash a bi. This is the formula. We have to find which production is having that both the things are equal. I equal to j. In that we have to collect the alpha value and beta value. Based on that, we can write the equation B3 and A3 is 3 is nothing but I. The I value here, the I value is 3, so B3 and A3 we have to write. In this, definitely one production, it is in the form of GNF. GNF is nothing but starts with a terminal and followed by the non-terminal. So the particular A3 is in the form of GNF. We can substitute this A3 in some other production. Already we have production 1 and 2. Equation 1 and 2, we can substitute this. Our aim is to get all the production in GNF format. All the production is in the right side start with a terminal. Like that, we are going to substitute. Okay, if we are substituting, finally, definitely we will get this answer. Okay, how many production you have in A2 or A1? You have to substitute all the production in the other further equation. Okay, this is the GNF. Please make a note of this problem. Have you noted? Have you noted, Pa? Please try this very, very simple problem. The same thing you are going to follow. Please note the formula. If both the things are equal, you have to follow this formula. How we can find the beta? The first production, you have to take the first production. Okay, in that first production, skip the same value. Which one having the same value of that particular leftmost element? Left side element. Just skip that element. Remaining things in the particular production is the beta, and skip the first production, and remaining productions are the alpha. Okay. Have we noted this problem? Anyone?
Yes, ma'am.
Okay, thank you. So now fourth one is started. In that we have seen the simplification of CFG and convert the CFG into CNF and convert the CFG into GNF. Okay, these are the three topics we have discussed. Now we are moving to the Turing machine. Okay. We know, right? It is most like related to the PDA, push down automata. What is push down automata? Anyone? What does mean by push down automata?
Ma'am, automata with a stack.
Okay, fine. Finite automata or finite state machine with stack. This is called push down automata. Like that, here also we are going to design a model or design a machine based on some condition. Okay, but here we are using the tape concept. In the case of push down automata, we are use the stack symbol, stack concept, right? In the case of stack, we can push the element and pop the element. Here we are using the tape, input tape. That is the infinite amount of tape we are using. Okay, we are just push all the values into the tape and read one by one. Okay, each and every process, each and single step we can do only one process. Okay, we'll see what is the Turing machine. It's invented by Alan Turing in 1936, and it is used to accept recursive enumerable language. I mean type 0 grammar. We know, right? How many types we have? Type 0, type 1, type 2, and type 3, right? The push down automata, we have studied type 2. This is the type 0 grammar. Okay, this is the particular grammar. Which are the language or which are the grammar is called as type 0. That grammar is accepted by the Turing machine. That means unrestricted. We can, no restriction here. We can accept based on the language, it will accept. Okay, a Turing machine consists of a tape infinite length on which read and writes operation can be performed. Okay, in this tape we can do read and write operation. The tape consists of infinite cells. Okay, the tape is divided into number of cells. Okay, on which each cell either contain input symbol or a special symbol called blank. It also consists of a head pointer which points to cell currently being read, and it can be moved in both the direction. Okay, this that's all about Turing machine. Turing machine is nothing. Listen, Turing machine is nothing but is infinite tape. Okay, the infinite tape is divided into number of cells. Each and every cells can store one element. Okay, with input symbol. Which element can be stored? Input symbol or blank symbol. Okay. For example, in push down automata, I have mentioned that after the string, we have that epsilon, right? Empty. Like that, here we are having blank symbol. Okay, the blank symbol is mentioned by delta. Okay, once the string is over, after the string, we have the symbol as delta. That is called blank symbol. Once the blank is reached, we can say the particular string is accepted by the machine. Okay. And we have one head pointer which is point to the cell currently being read. Okay, where we are at present, where we are, that is mentioned by head pointer. Okay, the tape having head pointer, with the help of this only we can find where the particular thing is happening now, recently or currently, where we are positioning, like that. Okay, and that the particular tape is can move both the direction. We can move to the left and so the right. Okay, these are the features of Turing machine. You please go through this. And this is the important, that is representation, how we can represent the Turing machine. This is the way we can represent input tape. This is the format of input tape. Okay, this is the format of input tape. The tape is divided into number of cells. Okay, this tape is divided into number of cells. Each cell can store single element or single input, and the particular tape also have the blank symbol. Okay, for example, my language is like L equal to A power n, B power n. Okay, same number of, equal number of A's and equal number of B's. Like that means I can have the value like this, A and A and B, again B, and after this string, one blank symbol is mentioned, that the string is over. This is called blank symbol. Okay, it is mentioned by delta. Okay, this is the way of representing the Turing machine. And finite control is there. It is nothing but is used to denote where currently I'm present. Okay, where where I'm reading now, like that. Okay, so I can move in this left direction or right direction. Okay, for example, now I'm here. Okay, now I'm here. The second A I'm here means I can move to the right. That is, I can read to the B or A also. The tape can move front and back also. It comprised of 7 tuples. Okay, what are they? Q, T, P, and these are the same, right? Already we have studied. Q means finite set of states, and this means the epsilon means finite set of input symbol, and this del is nothing but transition function, right? And next one is the initial state. This one is the final state, and these two elements are new to this Turing machine. Okay, this T is nothing but tape alphabet. For example, in push-down automata, we have stack symbol, right? In that particular stack, the particular input Z not and A may inserted, right? This is the stack symbol. So here also, what are the things we have entered into the particular tape, that is called tape alphabet. Okay, so symbols which can be written on the tape, this is called tape alphabet. And B is nothing but, already I have explained, that is blank symbol. It represents the end of the string. Okay, del is nothing but blank symbol. It represents the end of the string. Every cell is filled with B except input alphabet initially. Okay, once the input string is over, then it may be denote all the cells. After the input, all the cells are denoted by this del, that is called blank symbol. Okay, the remaining things are the same. And here the transition function, in the finite state machine, how we represent the transition function? Q0 comma A equal to Q1, like that, right? In push down automata, how we can represent? Q0 comma and state, then input and old top of the stack, and new state, new top of the stack, right? This is the way we can represent, we can write the transition function of PDA. But in the case of Turing machine, how we can write? Q is nothing but, this is the way we can write the transition function for Turing machine. Okay, Q is nothing but finite set of state. It may be anything, like Q0, Q1, it may be anything. Okay, and T is nothing but what? T is nothing but what? Tape alphabet. Okay, for example, what are the things present? What are the things inserted into the tape? That is called tape alphabet. It may be A or B, anything, right? Q0, this is the state. It may be, we can represent the transition function as A. Okay, and this is also number of, this is also set of state. After reading the input, the particular state is changed or not. If it changes means we have to mention the state, otherwise we have to keep the same state, right? Again, the T multiplied with L and R. L R is nothing but, I mean, this LR is nothing but left or right. After reading this input, we have to change something, like, for example, okay ma, in push down automata, how we check the particular language, but equal number of A's and B's, how we check? In push down automata, we have checked the language, right? L equal to A power n, B power n, that is equal number of A, equal number of B. How we can check? How we can check? Anyone please? How we did ma in push down automata? Anyone can reply please? How we check both the things are equal or both the things are A, B, C means how we can process, how we design the PDA.
Ma'am, if it is A, we push it into the stack.
Yes.
B, we copy it in.
Okay, ma, thank you. So if A means, if reading A, then we can push the particular A into stack. If we're reading B, then we can pop. Here, here also the same language, L equal to A power n, B power n. Okay, we have to mention the input in the form of tape. Okay, now I'm having that language is A power n, B power n. That is A A, B, B. Okay. Just I have taken this string. This is my tape. Okay. After the input, my tape is having the symbol as blank delta. Okay. This is my tape, input tape. Initially, my head is here. I'm just going to read the first input, first symbol. Here I'm going to do what means. In the case of A, the same language, right? L equal to A power n, B power n. I'm going to design a Turing machine which having that equal, which the language which having that equal number of A's and B's. I have to check how we can do means here. If I'm reading the A, I just read the A. After reading this, I just replaced with the some other value so that I can understand, yes, this variable is already read. Okay. What I'm going to do in this Turing machine, I'm just reading the first element. After reading this, I just change the particular terminal into some other variable. Okay, any variable, it may be x or y or z, anything. Maybe just I'm changing the value, because from that I can understand, yes, I have read that particular element. Okay, if any equal number of some other element, for this I'm reading that A, right? For that, if any equal number of B is there, then I can change into some other value. For example, I'm in the first position. I read that particular A and change to X and moving to the right. Moving to the right means next cell. Okay, I'm moving to the right. No need to change here. First of all, I need to find the equivalent value for this A, which I have already read. Okay, which I have already read. For that, I have to find the equivalent element. Okay, I have read one A is already I have read one A. I just change it to X. Then moving to the right. My position is now here. Okay, this is also A, right? Not equivalent value. This is the same value. Okay, I have to find the equivalent B. Equivalent for this A. This is the equivalent B. For this A, this is the equal. Both the things are equal, then we can say the particular language is accepted. Okay, so I'm moving to the right. Now I'm in the second cell. Okay, that is A. I'm in the second cell, that is A. No need to change anything, just I can move further. Okay, I'm moving to the right side, that is B, another input. Okay, so I can find that already I have read that one A. For that one A, if equivalent number of B is coming, so I can change the, I can read the particular B and change into Y. Okay, is it clear what I'm doing? I just want to do, already I have explained many times. As a human, we know we can see is equal number of A's and B's there, but system, how it calculating, this is the way only how it's calculating. This is the way the system programmed already. Okay, these are the Turing machine. Already I have explained. The Turing machine is nothing but is a simple computer. So not for a big problem, large problem, for a simple problem, we are going to design a simple computer in the name of TOC, Turing machine, push down automata, or finite state machine, like that. Okay, so for a system with the help of Turing machine, the concept of Turing machine we know. With the help of this, we are trying to teach the system that how to check the equal number of A's and B's. Okay, now I have found that for a single A, for a first A, I have found that respect to B is there. Okay, now my position is this one. First B, I read the B and change to Y. Okay, after that I can move to the left side, not a right side. Okay, for a single first A, I have found that equivalent B is found. So I just move to the left side. Okay, up to where I can where I can move means up to this X, because then only I know, right? Yes, this symbol is already read by myself. Okay, so now I can find that the A is changed by X, so I can mean that yes, this symbol is already read. So I can move again. Now I'm coming to this position. I can understand that this is already read. Change it to the next value. So I can move to the next position to the right. Okay, so my position is now in the second A. Okay, so this is a new A. For that I have to find the equivalent B. So how can I equalize? For this A, I just read, and after reading I can change this A to X. And moving to the next position. My next position is what? Y. That means the B is already equalized to the previous A. So I can move to the further position, next one. Now I can move here. Okay. Now my position is the second B. Yes. Now here the element is B only. So I can assume that is no other equivalent for this B. Now only I read it this A. For that I can equalize this B. Okay. So I can, after reading this, I can change to the particular B into Y. Okay. Now my all my values are changed. So that means I'm having 2x 2y. That means equal number of A's and equal number of B's. Finally, I move to the delta. After reading this delta, I can end my system. In the case of PDA, we have did with epsilon, right? After reading this epsilon, and I went to that particular final state and end my system. Like that, after reading this delta, we can move to the final state and complete our process. Okay. Okay. Now please tell me, if my language is L equal to A power n, B power n, C power n, then how can I equalize through this Turing machine? A power n, B power n, C power n. Then how can I equalize, or how can I design a Turing machine? Anyone? Anyone, please think and tell me. For A and B, I'm going to equalize. For that, I'm changing to the some other variable. Then I can conclude that yes, I read that element already and equalize with some other element. Now you please go with that language L equal to A power n, B power n, C power n. With the help of this Turing machine, how we can equalize, how we can find the particular language is following this concept. Students, please. Any idea? Is Satvika? Any idea, pa? Nitya, Tarun. Any idea how we can design Turing machine? How we can teach the system to check the particular language, that is equal number of A's, equal number of B's, equal number of C's. Then tell me how we can do. I'm audible. I'm audible.
Yes, ma'am.
Yes, ma'am. Yes, tell me, Satvika, any idea how we can do?
No idea, ma'am.
Why we are done with A power n, B power n? How we can go with A, B, C? Think and tell me. Anyone, please? Tarun, any idea?
Can we take the third variable as z and we can proceed like this?
Yes. Very good. So if you are reading this A, you can convert into X. Okay, first A, and then you move on to the right side. If you're reading the first B, you convert into Y. You can move forward further, that is move towards the right. If you're reading the first C, you can convert into a Z. Then you come back to the second A and second B, second C, and third A, third B, third C. Like that it's going, right? Can you able to catch what I'm telling? This is the way we can implement this language. Okay. What is our aim? We have to equalize the system, equalize the language. We are going to tell the particular language is accepted by the Turing machine. For this language only, we are going to design a Turing machine. So what is the concept here? Equal number of A, equal number of B, equal number of C. We have to equalize everything. but the system doesn't know anything, doesn't have brain. So we have to teach. If A is like this means we have to find the equivalent B, equivalent C. Then you can say all A and B occurred in one time. Then second B, second C, second B, second C. So you can say all A, B, C occurred in second time, and the third A, third B, third C. Then after that you can say the A, B, C occurred in third time. So we can likewise we can equalize. Okay, this is the concept. Any doubts? Any doubts? How we can represent the Turing machine the same way how we did PDA and push on automated. The transition diagram is there, transition table is there. Okay, and then instantaneous description. With the help of this we can say the particular string is accepted or not. Okay, for example, here they given the language is L equal to 0, 0, 1, 1. The same thing. Equal number of 0 and equal number of 1, right? How we can do? For first A, we just replace the particular, after reading this, we can replace with X. Then move to the this question. After reading the first input, we can change into Y. And then move left. Okay, move left. Then find the second value. Then change to particular X. Okay, then move to the right and second Y. So, sorry, second one we can change to Y. This is the way we can do. See how we can. First of all, my question is in the first element. After reading this, I have to change the particular 0 into A. X, Y, A, B, anything it may be. Okay. This is nothing but it is mentioned as blank symbol. Okay. This B is nothing but constant or blank symbol. If you can follow this one, this way, blank symbol. Okay. So 0 is changed with A. Then you can move right. Second 0, no need to change anything on the second 0 before you finding the equivalence of this A. Okay, can you able to follow what I'm telling? First you change the 0 into capital A. Second 0 not changed because I have to find the value equivalent to the particular A, right? So 1 is replaced with, now I'm reading this input. This is the different input. So I can equalize to the previous one. This is replaced with B. Okay. It is replaced with B. After replacing this B, I can move to the left for finding the next element in the 0. Okay. Next occurrence of 0. Like that we can say, like next occurrence. Then after reading this 0, I can change to the A, capital A. Then I can move to the right. Okay, I can move to the right. So here B, and I have to find the equivalent value for this A. So the 1 is again replaced with B. So now my string is having. How can I find the string is over? We can come here. Otherwise, I can go with that blank symbol. If the blank symbol is reached, I can say the particular string is over. Okay, this is the simulation. This is the way we can do. This is the transition diagram. I have to start with the initial state Q0. I will start with the initial state Q0. In that, I'm going to do what? First, what is the first step? I'm reading the input 0 and changing to the capital A and moving towards the right. Okay, this is the thing mentioned. I have reading the input 0 and changed to capital A, and this is the direction right. So I have to mention with the right. Okay, this is the input. How we can mention the transition function? Input is replaced by the capital A. Okay, and I'm moving to the right direction. Okay, this is the transition function in Turing machine. Okay, ma? Any doubts so far? Then what's the next step? I'm just replace the 0 with A and moving to the right. Here only I'm here only. What is the process? Just reading the input 0. Keep the same, no changes. Just moving to the right. So I can say input is 0. There is no change. So I can have the same value. 0 is no change in the particular value. 0 is changed to 0 and moving to the right position. Okay. Any doubts? What is the next step? 0 is replaced with the same 0 and moving to the right. My value now my value is 1. So the another input, next input, right? So this is changed to B. Okay. 1 is read and change it to B and moving to the left. Okay, not a right here. 1. Okay. I will draw tomorrow in next class. I will draw and explain. Okay. Okay. Time is over, I think so. Any doubt on Turing machine, ma? Don't panic. With more example, we can understand some limited repeated questions only there. Okay. So don't worry about it. You can handle this Turing machine like PDA. In board means in offline class it will be easy to convey my thoughts and my lecture to you. It is somewhat difficult in online. Anyhow, if you have any doubt, definitely you can ask me. Okay. It is like PDA only. Each and every concept may have some difference based on the concept, but the representation are same. The transition function or transition diagram, everything same for all the problem. Some little concept change only that. Okay, don't panic. With the more practice, we can able to go through. Okay, we'll see in the next class. Thank you, students.